Hi, this video is to show you how to use Excel to apply and use the sampling distribution to solve problems. Okay, so we're going to use Excel to solve this problem here. What this problem is talking about is we have a proportion of employees taking management training. So the proportion of employees is 0.6. This is the population proportion because the P doesn't have a bar on top of it. Because it doesn't have a bar is the population proportion. So the population proportion in this case is 0.6, which is 60% of employees in this company are having classes, are having management training programs. Okay, so what we want to know is what is the probability that a sample of 30 employees can provide an estimate of this proportion that is within plus or minus 0.05 of this actual population proportion. So what we want to know is we want to establish certain limits for where the estimate of the sample proportion can be. Okay, what's the probability that a sample will give us an estimate between these two numbers? That's another way of saying the same thing. That's what we want to know. Okay, so that's the question, and many of the homework assignment problems are very similar. They're asking what's the probabilities. And I have the steps, and in the previous video I showed you how to go on these steps by hand and using this process on my slides. Okay, so let's go over them on Excel. The first step is check the conditions. We have to check if this multiplication of sample size by population proportion is higher than 5, and if this multiplication of sample size multiplied by 1 minus proportion is higher than 5. So we go to Excel. This is the file EAI sampling distribution application. And I have the sample size 30, the population size of 2500. They come from the problem. And this is what I have to do. I have to check these conditions here. So let's do this. First step. These are the conditions. So what I have to do is the sample size 30 multiplied by the proportion here, which is 0.6, 0.6. That's the condition. 18. So this one matches. Let's see this one. So I have n is the sample size. Sample size is 30 multiplied by open parentheses 1 minus the proportion is 0.6, 0.6, close parentheses, and I match this condition. Okay, so that's the conditions. Okay, check it here, check it here. These conditions match the requirements. Okay, so 12 is higher than 5, 18 is higher than 5. We can move on to the step 2. Step 2, compute sample size over population size to determine if you need the correction factor. I talked about the correction factor, which is the finite formula in the previous video. So watch if you don't remember. Okay. So to figure out if we have to use the finite or infinite formula, we have to do this. Okay. So here we go. We get the sample size 30 divided by the population size 2500 is 0.012. If you want to use only 2 decimals, you can reduce, and then you can see that this number is less than 0.05. That's our threshold limit. If it is less than 0.05, you can use the infinite formula. Okay, so we're gonna use the infinite formula in the next step. We can move on to the next step. Next step is compute the standard error of proportion, and then here is you have to use the infinite formula that you check it here, and you see that you have to use it in this step. Okay, so this is the formula. It's proportion multiplied by 1 minus proportion divided by sample size, and then we take the square root. So here's step 3. Here is like another way of saying this formula: square root of p multiplied by 1 minus p divided by n. So let's implement that in Excel here. So to do that, we type equal SKRT, okay, and then we open parentheses, and then we open parentheses again, 2 parentheses, and then we do how much is the P, how much is the proportion, 0.6, given in the problem, and then we multiply that by open parentheses, 1 minus 0.6, we close parentheses, we closed parentheses again. So now all this multiplication is within parentheses, and then we divide it by the sample size, which is 30, and then we close the last parenthesis, and then we type in and we get 0.0894. Okay, we got the standard error. We can move to step 4 and 5. Step 4, calculate the upper endpoint and the lower endpoint. How we do that? We get the proportion and we add the desired value. Both are given in the problem. So the problem says within plus and minus 0.05. So we get the proportion and we add 0.05. We get the proportion and we subtract 0.05. We get the upper and lower endpoint of the interval, which is shown here and again. Okay. So we did that. This one is pretty easy. I'm not going to use Excel. It's very straightforward. So it's here. I just type it, and then we can move to step 6 and 7. So step 6 and 7 is use Excel to find the answer. Okay. So let's use Excel. I'm going to implement this in Excel, the exactly same formula, and I'm going to get the answer. So to do this, I'm going to do first for the upper, for this number upper, so equal norm dot dist, open parentheses. So the first number I have to enter is the upper endpoint, which is 0.65, and then I type comma. Then for the mean here, I enter the proportion 0.6, then I type comma, and for the standard deviation, I enter the standard error, which is 0.0894. I type comma. For the cumulative, I type 1, close parentheses, and I get the answer, which is the same answer I have here. Okay, now I'm gonna do to the lower endpoint, which is the same thing, but I'm gonna use the lower endpoint number. Okay, open parentheses. So instead of 0.65, I'm gonna enter 0.55, and then the proportion is 0.6, the standard deviation is 0.0894, and I type 1 for the cumulative, and I get this number right here. Okay, so we got the upper and lower endpoints. Now we have to subtract one from the other. That's the last step. Calculate the area under the curve between the lower and endpoints, which means subtract the areas you found in steps 6 and 7. So if you subtract them, which is the answer here, I could do this, equal this minus this. That's the same answer. We got it. That's the probability. That's the final answer. Okay, so that's the probability. That's the probability that a sample of 30 employees provide an estimate of the population proportion within plus or minus 0.05 of the actual population proportion. So the probability is 0.4240. It's not a high probability. Okay, so this is how you use Excel to use an applied problem of sampling distribution. Okay, solving the problem in Excel. That's it. Bye.